In this video, we're going to have a look at compound interest, what's the difference between compound interest and simple interest, and have a look at a couple of examples of how you can calculate this type of interest in a few different situations. So the first thing that we need to talk about is, well, what's the difference between simple interest and compound interest, aside from the fact that the formulas are different? Well, with simple interest, we earn the same amount of interest in every single compounding period. So if you invest some money and you invest it for 5 years, you'll get back the same amount for every single year. And that doesn't change. Sometimes it gets called a flat amount of interest. Flat meaning that it doesn't increase or decrease. It's always the same amount that you get every single year. Whereas with compound interest, if you invest that same amount of money, the amount of interest you earn each year changes, because not only do you earn that interest at the end of the first period, so it could be the end of the month, that amount goes back into that investment account, and now your total is a little bit bigger. So when they calculate the interest for the next month, they use that new balance. So every single month, your interest gets added back into the balance, and the following month, when they go and recalculate your interest, they're basing it on a slightly bigger amount. So we'll have a look at a couple of examples of how you can do this using a compound interest formula. Let's have a look at an example together. So Kathy invests $10,000 in an investment account which pays 2.5% per annum, so PA often means per annum, compounding yearly. So this is where this is different to some of our simple interest questions. Compounding yearly meaning the interest gets calculated at the end of every year. So here's our question. What is Kathy's investment worth after 1, 2, and 3 years? So we're going to actually have to calculate 3 different answers. Let's have a look. First of all, we need to have a look at our formula and figure out where can we substitute some values in. So up here we can see that V0 is the initial value. So we know that Kathy's starting off with $10,000. So our initial value is going to be 10,000. Now R is the common ratio, or in this case, the interest rate. So we can see here that our interest rate is 2.45% per annum. So let's pop that in here, 2.45. And then N is the number of compounding periods. So we're going to do this a few times. First of all, we'll work out how much is the investment worth after 1 year. So in this case, we're going to substitute 1 into the spot where N is. Let's have a go. So V1, so I'm working out after the first year. So V0, that's going to be 10,000. Then we're going to multiply that by 1 plus. Now this is an investment, so it's going to grow, so I'm using a plus. 2.45 over 100, all to the power of 1. And you'll notice that the 1 here and the 1 here match, just like they do in this little template that we've got. So at this point, you would get your CAS calculator out, you would type this stuff into your CAS, and you would see what you would get. Okay, so that means that the investment is now worth, as we can see, 10245. Let's have a look now after 2 years. So this time we're working at V2. So we use the same formula again. The difference now is we'll raise it to the power of 2. Now let's see what happens. Well, so this time around, our investment, is worth $6 and we'll say no cents because we'd round up, and yeah, we wouldn't round up. Now you'll notice that the first investment grew by exactly $245. So it started off at 10,000 and it grew by this much, 245. But the jump from year 1 to year 2 wasn't exactly another 245. And I've worked it out here. The difference from year 1 to 2 is actually $251. So you can see with the second year it grew by a larger amount. So this is what happens with compound interest. After every compounding period, because we add the interest back into the investment, it's going to grow even bigger and bigger and bigger. Let's finally have a look at what happens with year 3. Wow. So you can see now that Kathy's investment is worth $10,753.15. And if you remember, the jump from V0, which is really the initial investment, was an extra $245. Now the jump from here to here was roughly an extra 251, I think, from memory. But now the jump from the second year to the third year is $257.15. So you can see after each year, the amount of interest that gets added back in gets bigger and bigger and bigger. So you can imagine what would happen after maybe not 1, 2, and 3 years, but 10 years, 20 years, 30 years. The amount of interest that will get added each time will increase at a much larger rate. Let's have a look at something a little bit different. This time, Patricia wants to invest $20,000. Oh, here we go. So $20,000 is V0. So 20,000, I'm just going to write this in as I read. It's her starting balance. So she wants to invest $20,000 and eventually grow her investment to 25. If the bank offers her 3.3% per annum interest compounding yearly, how long will this take? Okay, so we know that the interest rate is 3.3%, but we don't know how long we're going to invest for. This part we actually need to figure out ourselves. So if we were to substitute all of this information into a little formula, it would look something like this. Here we go. So rather than writing V1 or V2 or V3 because we don't know how long, we've actually put 25,000 in. That's how much Patricia wants to eventually get to. What we don't know is what number needs to be in this spot for this equation to be true and to work. So what we could do is we could rearrange this, or even easier, we could use our CAS solve function to figure out, well, what number would go in that spot to make this investment grow to $25,000. Let's have a look. Okay, so I've used the solve function and I've typed this in. I've used the letter N. You could use X, you could use Q, doesn't matter. And then I've told my CAS to solve for N. So I'll put comma N on the end. Here we go. So it says after 6.87 years, my investment, or Patricia's investment, will eventually get to $25,000. So if Patricia has to wait till the end of every year, if she can't take it out partway through, how many years would she have to wait? Well, 6 years wouldn't quite make it, because 6 years won't quite get Patricia to $25,000. It'll happen somewhere between the 6th and the 7th year. So we would say in this case that it would take Patricia 7 years, because after the 7th year, it'll definitely flick over to $25,000. So it would take her 7 years to get to that particular amount. So in this example, we're going to have a look at what happens when you invest something, but rather than compounding yearly, we're going to compound at a different amount of time. So in this case, it's monthly. So Ian is investing $70,000 at a rate of 2.4% compounding monthly. So this is the different part about this question. What's the value of the investment after 5 years? Well, we use our same formula, but we just need to tweak a couple of things if we're compounding at a different rate. So if we're compounding monthly or weekly or fortnightly. So let's have a look at how the formula looks this time. Okay, so much of it's the same. Our V0 is still 70,000. It's what we're starting with. We're still looking to find V5, but we might change that in a sec. But I've left a couple of spots empty. Now, our interest rate is 2.4%. Now, that'll be a yearly interest rate, but we're compounding monthly. That just means that every month the interest is calculated and added in, not at the end of every year. So it's happening more frequently. So what we do is we pop in our interest rate, our per annum interest rate, and we divide it by 12. So what it does is it turns that yearly interest rate into an equivalent monthly interest rate. So it chops it up into 12 equal pieces for each of the months of the year. So whenever we compound monthly, we divide our interest rate by 12. Now with N up the top, now rather than just popping in the number 5, which, this question talks about 5 years, we're talking months this time. So we can't just put in the number 5 because that'll spit out how much Ian will have after 5 months. So up here, we need to say, well, 5 times 12. 5 years times 12 months. Now you can work that out and put a number in that spot, or you can just type it into your calculator just like this. So in this case, what we're looking to find is not V5, but V60. So 60 months is the same as 5 years. So other than changing the interest rate part up here and changing n, the compounding periods, the rest of it's the same. Type this into your CAS, see what you come out with for V60. Great, so here we can see we've popped it into our CAS calculator and the adjustments that we've made, the compounding periods instead of 5 at 60, so 5 times 12, and the interest rate, we've said it's 2.4% divided by 12 over 100. So Ian would have, after 5 years, $78,915.32. So that's compounding monthly. Now, I'm curious to know, how is it different to if he invested with it compounding yearly? Will it be more? Will it be less? Let's have a look. So we'd have exactly the same formula. So I'm going to pretty much write out the same thing, except this time we're going to work out V5. So this is after 5 years. 1 plus 2.4%. So this is like what we've been doing previously to the power of 5. So what it means is interest is only going to be calculated 5 times, once for each year, not 12 times in every year. Let's see what happens this time. Okay, so this time, if it's compounding yearly, so 5 times, once for every year, we get a different amount. This time, Ian would earn $78,812.99. So we can see it's actually a bit less. So this is 800 and that's 900. So if you compound more frequently, more often, you earn money faster in the same amount of time. So we can see compounding monthly, it's more than an extra $100. If we compounded fortnightly or weekly or daily, so if the interest is calculated every single day and that interest is put back into the investment account and then recalculated the next day, you'd notice that it would grow even faster. So the more frequently you compound, the faster your interest grows. So the thing to remember here is if it's compounding something other than yearly, monthly, weekly, fortnightly, you just need to adjust your interest rate. So in this case, divided by 12 and adjust the number of compounding periods. So if it's 5 years, but we're talking months, it's got to be 5 times 12. So if we're talking about weeks, we would divide by 52 for the interest rate. Well, sorry, lost my thing. So that's weeks. If we're talking fortnights, we'd have to divide by 26. And if we're talking days, we'd divide by 365 because there's 365 of those in a year. And similarly for the number of compounding periods up the top, so over here, we would multiply by the same thing.